Hello, folks. Welcome to my YouTube channel, Swifty LeetCode. How are you guys doing? I'm doing well. Hey, today we have a very interesting problem. It's called remove invalid parentheses. Honestly, this is one of my favorite problems. And the reason is that it not only checks your, parenthesis validity concepts, but it also checks your BFS concept. Because in order to solve this problem, I'm not saying this is the only way to solve the problem, maybe there are more ways, but the way I'm going to solve this problem is through BFS. So, and again, it's you're going to love it. It seems intimidating, but once you follow through, it's not that hard. So what the problem is saying, the problem is saying that remove the minimum number of invalid parentheses. And second thing, return all possible results. So what it means is that if you have an input like this, what is the minimum number of parentheses you need to remove in order to make it a valid one? So here, if you look at this input and output, you see that the first output you got is from removing either this guy or this guy, same result, right? And the second output you got is by removing this guy, the second character. So the minimum number of parentheses to remove to make this valid is just one. So the idea is how many valid unique combinations you can come up with by removing one parenthesis. And that one could be this guy, the second guy, the third guy, fourth guy, whichever guy. But once you have found that the minimum number of parentheses to remove is just one, then you stick with that number one. You don't go to two, because it says that the minimum number to remove. How are we going to attempt this problem? Let's look at this one. It's open, close, then close, open, close. Okay. So we have open, close, close, and open and close. The way we're going to solve this problem, as I said, is through BFS. And BFS uses usually the standard algorithm to solve BFS is using two queues. One we call outer queue, and there would be another one which is inner queue. Okay. So, and how, let's represent this into tree, and I will also explain how I'm going to solve this. So let's consider this guy as the root node of a tree. Okay. By the way, this is not a binary tree, it's a tree. So this could have as many children, it's could have many children, not just two, just for the record. The way we're going to solve this is that this is the root, and I'm going to put it into also the outer queue. Once in the outer queue, this guy, I'm going to remove it from the outer queue and put it in our inner queue and empty it. And it will make sense once follow along. Inner queue is open, close, open, close, close, open, close, right? And we're gonna erase, the outer queue. And once we're gonna process the inner queue, the first character we will remove with this. By the way, there would be some alphabets or letters too in this input. So we're gonna skip that. We're gonna basically, kind of ignore that. It will be still a part of your string, but we'll not process them. So first we found an opening brace. We're going to remove that, and the string remaining we'll got is close, open, close, close, open, close. Next item in our outer queue, we'll remove the second element, right? And then it will be open, open, close, close, open, close. Third element, we'll remove the third guy. So open, close, 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 open, close. Then fourth guy, and similarly. And the idea is all these will become like children of this. All these are the children of your parent root. You see, so let's say if this is 1, 2, 3, this is just hypothetical. We're gonna use 1, 2, 3 in our algorithm, but just so that I don't have to write that much. So that guy, all these 1, 2, dot, dot, dot are your children. Now the idea is you're gonna check each one for the validity. So we will have a validity algorithm that if this string, whatever we got, like for example, this guy, it's not valid. It's starting with close, so it's not valid. So every guy will go through this validity check. If it's valid, then we will have our kind of result array. Um, you know, let me put it here, and this will we will start appending. If it's valid, this is result. Valid, then put it there. So, we're going to process each one of them. So first of all, by the way, my bad. First of all, once we're going to get everything in the outer queue, the first thing what we need to do is that put everything back to inner queue. So this will be removed, of course, and we will put everything from the outer queue to inner queue, and we're going to process everything. So it's breadth first search, right? The first node get processed, then all the children on the first level gets processed. And that's how you achieve this, is by clearing the outer queue, putting everything in the inner queue, process each element, and then let's say the first guy, we move all of them to here, and then the first guy goes through validity check, and not this won't go through the validity check, but this guy will go to validity check, and valid is gonna go to the result. If it's not valid, then what are we gonna do? We're gonna do the same thing. Let's say this is not valid, so we're gonna process it to the same algorithm, which will remove each character and put it back into the outer queue. So all of this will be gone when we move it to the inner queue. And then, for example, for the first guy, I did not write it here. That will be your kind of close, open, close, close, open, close. This is not valid. So all the children of this, after removing each element, so first how the first element is gonna look like. Remove the first guy, it will be open, close, close, open, close. And similarly, what will be the second guy? Remove this, it will be close, 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 open, close. So after every inner child like this level gets processed, all the valid one will be appended into the result, and all the invalid ones will be processed over here. Now, catch over here. If any element in this, like let's say this is the root level and this is the first level, if any element is valid, we not gonna process the third level, because hey, at this point we know at least one is valid. So how we get the first element? By removing one character. How we get the second level? By removing two characters and follow on. So if we already have at least one valid result in first level, we're not gonna process the second level, because that is the minimum number of minimum number of characters or parentheses to remove to make the string valid. But let's say second guy is valid, we're still going to process third, fourth, and fifth, and so on, but we're not going to process children of any of these. Make sense? All right, cool. So with that in mind, let's take a shot at it. Okay. All right, so first thing first, let's create a function which will check the validity. So func, it's valid, and input is gonna be string and bool. Okay, and here, if you have followed me, my video on how to check the validity, there were three kinds of parentheses. Here is just one kind of parenthesis. It's this guy. So we don't have to go through that dictionary approach. We can just count. So what I'm saying is that we can say var count is equal to 0. We'll start with 0. We will say that for ch in input, and ch letter. So if it's letter, we're gonna skip it. So if ch is equal to open, then we will say count plus is equal to 1. We're gonna increase the count. Else, we're gonna see if count is equal to 0, which means that if you have a closing bracket but there was no open one, or if there was an open one and there are already closing brackets which is negating it. So if basically count is it's a closing bracket without a without prior an opening bracket, then we can just return false because it's invalid. Else count minus is equal to 1, right? It's just so every opening is incrementing a count, every closing is going to decrement a count. And finally, at the end of it, you're going to just return equal to 0. Makes sense, right? So if ultimately count is 0, then it's valid. If it's not, then it's invalid. Okay, that completes our isValid function. Now, over here, let's say, so we know we're going to work with two queues, and in Swift, we can just create a regular array. So let's say var outer queue is equal to var inner queue. Oh, not int, characters. We also need a set, so just so that we are not repeating ourselves. If removing, let's say, third guy is same as removing the fifth guy, then we don't want to process it twice. So let's also create a set. By the way, this should be string because we are gonna store, I don't know what I was thinking. Yeah, string. Okay. And we should also have a result one to append the result. Okay. With that in mind, let's insert the input, which is s, to our outer queue first to begin with. So append, and we're gonna say s. Okay. So with that, and as we said that once we find an answer, then we're not gonna move to the next level. To cater that, we will also have a variable called found, which is false, right? And we'll start our loop. So our outer loop will say while outer q dot count is greater than 0 and found and not found. So found is equal to false, right? What we're gonna do here, we're gonna move all the elements from outer to inner. inner queue is equal to array of outer queue. That will copy everything from the outer queue to the inner queue. And then we want to remove or empty our outer queue. Okay. Then we'll start our inner while. So while inner queue, let's process our inner queue basically. Not count greater than 0. Okay, in inner queue, what we are doing is that we are taking one element at a time from the, so it's a queue, so from the bottom. So let first is equal to dot first. Okay, and so that will remove the very first element. Now we're gonna say if it's valid. So if is valid first, then we're gonna put it into our result. Append first, and we're gonna also mark our found is equal to true, so it doesn't go to the deeper level. So if valid is equal to this, else if it's not valid, then what do we want to do? We are processing that element and generating its children, which will be like removing one character at a time. So for ich in first, we're gonna say if ch is letter, then let's not process that. So actually, let's just do it here. Not ch, right? So that, and the idea is to create a string, create a substring, right? So we're gonna remove one character at a time. So one way to do that in Swift will be, let's create this, let arr is equal to first, and let str is equal to string. Okay. And so what this means is like take the subarray from 0th element to I minus 1 element and plus and triple dot means like to the end and I plus 1. So we are skipping the ith element over here and I gives index over here, right? Okay, so let's type here. Okay, that will create a substring for this this string first, and with the substring now, first thing we need to check if it does not exist in the set, because if it exists, we're not going to process that, right? So if str, if it does not, then set dot insert str. Let's put it into the set for further processing, and we also gonna now put this string into outer queue, right? Because outer queue is now empty and it's ready for taking the children of the next level. str, right? So if it's not valid, then we're going to process that and get all the children of that element we are probably. We have to return result, right? Let's just quickly see if we made any mistake. So here what I forgot to do is enumerate it. Okay, in order to do this kind of thing, you have to use enumerated. Now let's give it a shot. I don't know. That's kind of stupid, but whatever. Okay, same thing over. So if it's letter, then basically continue, right? Okay, accepted. Cool. Let's try to submit it. All right, perfect. This concludes this video. Although I feel like there is one small optimization we can do, is that let's say if the second element, let's say you have 5 children at a level, and if the second element we found that is valid, we actually don't need to process the third element, fourth element, and fifth element if they are not valid. We do need to check their validity to see how many valid answers are there at that level, but we don't need to go further down. So here and here we can just say that if found is equal to true, then continue. I don't need to, oops, continue. I don't need to process you again. And currently, I don't actually rely on this. Sometimes I feel that if server is fast for LeetCode, it's give you greater percentage. But I know for the fact that this should help, you know. So let's just give it a shot, and hopefully we are at the same server speed and internet speed, and maybe we'll get some optimized percentage over here. Submit. All right, we got it. All right, so that was just a small optimization I felt should be there. But apart from that, works good. Hey, I hope you guys enjoyed it. It's one of my favorite question. I really love it, and I think it not only tests your knowledge on parenthesis validity, but also tests your knowledge on tree or BFS. So again, thanks for watching it. Stay tuned, like, and subscribe. That really helps. Thank you.